now I would like to introduce you to Kelly Lockhart and Alberto Accomasi, leading the NASA ADS program, the Astrophysics Data System. They're both with CFA, the Center for Astrophysics at Harvard. And assume you're going to talk about ADS and NLP, some of our favorite acronyms.
Yeah, thank you. Thank you for the opportunity to talk. Last week, I was trying to convince Kelly to give this talk, and she was trying to convince me to do the same. So this is how we landed. We're going to split it down the middle. I will focus more on the policy aspects and long-term plans of what we have, and then Kelly will talk more about the technical details and the actual projects that we have ongoing. But I would also like to say that it's great to be at a workshop with so many people who have similar interests, and as it will become apparent once we start telling you what we're thinking about. So, all right. So I know most of you here at the ESA know what ADS is. Hopefully all astronomers use it, but I know there are some people who are not astronomers themselves. Just so as a recap, this slide is here to let you know that ADS is a tool for professional astronomers. It's a database of focusing on the literature, but increasingly indexes more research products such as software and data sets. But it also has been expanding. As of 2022, we're officially indexing the planetary science and heliophysics literature as we do with astrophysics. And everything that we do revolves around finding the right content and then enriching it and linking it to other resources. So one thing that changed recently is that in 2022, after we started adding planetary science and heliophysics, NASA, our funding agency, asked us to expand our services even further to include all of the disciplines that NASA sort of covers. And the biggest one is Earth Science, but there's also another directorate called the Biological and Physical Sciences that deals with sort of experiments, effect of radiation on human body and weightlessness and so on. So now, even though we remain the NASA Astrophysics Data System as a portal to the content in astronomy, the underlying database will also include records in these other disciplines. And this actually sort of changes the equation in terms of what we will need to do in the future for all of these disciplines. So we're going to be covering the Earth and space sciences as a general goal. So the entire system, as I mentioned, is based on a single database and microservices, so a single API. But there will be different collections. And if you've noticed that ADS is growing, the corpus is growing at a fast clip, is because we've already added more than 8 million records, which are for the Earth Science collection. So even this new data set dwarfs what we have for astronomy, which is about 3 million metadata records. And at the same time, we're also acquiring and indexing the full text of all the papers. So we have more than 10 million documents, most of which are original papers from the publishers. So they're not archive records or open access publications. And of course, we track citations and we have data collections. So all of these, I'm letting you know that it's not just about the corpus itself. There's a lot of metadata that associates records to each other, which are very interesting for data science projects. Okay, and so why is it relevant to you? Well, when we were writing the proposal, the solicited proposal from NASA, we realized that we could not do any of this by hiring an army of librarians and start typing all these records in the system. So the key here is to use technology to be able to do things more efficiently and also to be able to do new things that we couldn't dream of a while ago. So this paragraph was taken from the proposal that we submitted to NASA. And as you can see, it was before ChatGPT became so popular, but it was clear that NLP and AI were becoming major sources of technology that we could use in our system. And the other goal here is that this wouldn't be a static effort, but we want to be in a state of continuous improvement going forward. It also became clear very fast, certainly after the first large language models were published, that we couldn't keep up. So at that point in early 2022, we had created AstroBERT, which is a language model, but it's not a large language model. It has about 100 million parameters. And we started using it for some NLP tasks internally, but we couldn't really train our own model, our own large language model, and we all know how expensive that is. So it was clear that we wanted to use these technologies going forward, but that we couldn't do this alone. And so, one of my plea here is that by working together with this community, we can go farther than any of us could separately. And I hope we, in the spirit of collaboration, we all benefit from each other. So some guiding principles that we have to stick by. Some of these obviously are dictated by our interest in being fair and accurate, but some of them actually have legal implications. So first of all, we want to develop models workflows, techniques that provide high accuracy. Our database is a respected system which researchers trust, and so we can't just introduce something that would give wrong answers. We care about privacy, so there's issues associated with privacy. When you do text mining, you have to make sure that you don't expose them, and there's various laws that concern this. We also need to respect agreements that we have with the publishers. Just because a paper is published in the open, it doesn't mean that the license associated with it allows you to do certain things, such as using generative models. And also there's some ethical rules that we have to abide by as part of the Smithsonian Institution. There's a specific set of rules that we will follow. So all of these things are, if you will, they're constraints, but they're strong principles that need to be taken into account when we go forward. So what are the things that we can do for ourselves and for you? One of the first things we're trying to do is negotiating with the publishers who give us the material that we index in our system, the ability to use their content to develop AI tools. So again, we want to use the AppJ and ANA and monthly notices to create a model that works better, or to fine-tune a model that works better than what's around today. So already this is a concession that some publishers will make, but not everybody. You might have read that Wiley and Taylor and Francis are selling their content to Microsoft for tens of millions of dollars. So publishers know that they can monetize this. And so if they can make money, they're not just going to give it up for free. Fortunately, astronomical societies tend to be aligned with our principles. So the AAS has recently agreed to it, and ANA has voiced support. So I hope that at least for the core research astronomy papers, we'll be able to do this. The other thing we'd like to do, and we've been starting these partnerships with, again, the AAS, is that become a conduit to sharing this content, the content that they provide to us, so full text, potentially copyrighted content, that it be shared with research projects, such as the projects that are represented here. And, this requires the group wanting to use this content to articulate in a research proposal what they intend to do and what comes out of it. So we were hoping to be able to have some of this content available to the people at this workshop. Unfortunately, it's a bit premature. There's more things that the AAS has to approve before this can become possible. But we were getting ready to announce this program called the Trusted Partner Program. In the future, I expect that in early 2025, we may have all the 3 major publishers in astronomy agreed to this. And so there'll be a corpus available to do research with if you're interested in. The third thing is that, and this is a pet project of mine, is to be able to more widely share community curated data sets. For instance, there are data sets, labeled data sets that can be extracted from bibliographies that different projects maintain. Josh Peak here is representing Space Telescope. They have a great database of publications related to the Hubble Space Telescope, JWST, and so on. At the CFA, we have Chandra bibliography, we have an institutional bibliography. So these are curated sets of papers that use data from one or more missions. These could be used for training purposes to teach our AI assistants to do the work that now humans are doing, or to at least streamline the process and codify the principles behind what the librarians are doing. So one of my hopes is that some of these projects that have agreed to share these data sets, currently they're just all over the map. So one of my hope is that we can have a useful data set that spans across them. And at this point, I will let Kelly continue. Yeah.
Hi guys, my name is Kelly Lockhart. I'm the head of technology for ADS. So I want to talk a little bit about some of our current initiatives and projects that we're working on internally. So I think about these and divided into 3 separate buckets. We have data sets that we're curating. We have data enrichment pipelines we're working on. And then also we're exploring some data discovery tools. And I'll talk a little bit more about each of these. But I want to say that one of our guiding principles at ADS is open science. And so for all of these, we're trying to make them as open as possible. So we're making our data sets public, we're making models we train public, and also all of the tools that we're developing are really designed to benefit ADS users. Okay, so first up is the machine learning models that we're working on. We have 2 main ones that we're working on right now, AstroBERT and Indus. So AstroBERT is exclusively done by ADS. So we took a BERT model and we've pre-trained it using the astronomy corpus in a variety of ways. We fine-tuned it for various different tasks. One of those is this named entity recognition deal model, which I'll talk about more on the next slide. The other one is Indus, and this was made in conjunction with NASA SMD, the Science Mission Directorate. So all of these groups from SMD, from all the various SMD disciplines, have contributed data to this Indus project. So ADS SciEx contributed something like 40% of the data. So it's a lot of astronomy and planetary science data. But then, of course, the heliophysics community, planetary science, earth science, and BPS, which is biological and physical sciences, all contributed data as well. So it's not meant to be just an astronomy model, but it's meant to be useful for all of NASA SMD missions. So that one's fairly new. That one was just released a few months ago, and we worked on it in conjunction with IBM. And we've also been curating a lot of machine learning data sets. So specifically, most of the data sets we've been curating were for these WISP workshops, workshop for information extraction of the scientific literature, which are run in conjunction with this conference series. So we've been running one of these workshops every year for the last few years. 2024 got skipped because they're not running the workshop in the exact same way, the conference in the same way this year. But for the last few years, we've curated one of these data sets in conjunction with the workshop as part of a shared task. So teams from around the world can participate in this task and submit their models, submit their code to get judged to see who does the best basically on these shared tasks. It's a competition, kind of like Kaggle or something. So these data sets are now public. They're up on Hugging Face, so anybody can use them. You can use them for the tasks that are here or for whatever else. So the first one is a named entity recognition data set. So we've actually had somebody on our staff go through, an astronomer on our staff go through and label things by hand, so expert curated. The next one is function of citation in the astrophysics literature. So the same astronomer went through and labeled each of these citations in the literature. He took a bunch of paragraphs randomly generated from the astronomy literature, labeled where the citation is, labeled where that citation was mentioned in the text and what it was used for. So that's what the screenshot is. You probably can't see it very well. But basically you can say, like, was the citation used for background? Is it used, or is somebody arguing against this particular citation? So all of that's in there. So this is a hot topic right now in NLP spaces, trying to figure out why citations are used and being able to generate this automatically. And then the final one I list, AstroBibPile, is the one Alberto was talking about that we're working on in conjunction with MAST and Chandra. So we're hoping to run that one for next year's WISP workshop. So keep an eye out over the next few months for that announcement. Okay, so moving on to data enrichment pipelines. We are working on two different styles of data enrichment pipelines right now, one of which is in production. So the planetary feature identification pipeline is in production. I'll talk about that more in a second. And the other one is more of a keyword and category tagging, which we're still working on. It's still in development. So the planetary feature pipeline, let me give you some background about what exactly this is. So y'all are in astronomy, you're probably familiar with NED or SIMBAD, these databases where they say, like, you're looking at this particular galaxy. You want to see all of the papers that mention M31, the Andromeda Galaxy. And we're used to, in astronomy, there are a team of documentalists at SIMBAD, at CDS, who go through and read all these papers, and they say, like, yes, this is an M31 paper. They're not just mentioning Andromeda for some other random reason. Like, this is truly an Andromeda paper. And then they extract all this information about these objects and put it together in a nice database and link to the literature. And so we know for sure, like, these are the M31 papers. I trust this data. Planetary scientists don't have that same database. So we're trying to create something for them, but using machine learning instead. So we've developed this planetary feature pipeline, and these are all the steps, and we don't really have to get into it right now. It's up on, there's a 2023 paper on arXiv showing all of this. But basically we can go through and do some paper searches, and then we run various scoring techniques and NER methods to go and identify where we mention a particular crater, for example, and try to identify, like, when you're saying Apollo crater or something like Cassini. Cassini is used everywhere in the literature. You know, we have Cassini missions and Cassini features and things like that. So when we say Cassini, what do we mean by Cassini? Or when we say Apollo, what do we mean by Apollo? That's actually a pretty hard task because we reuse the same names over and over again, especially in planetary science. So what do we mean by that? How do we know if something's on Mars or the moon or wherever else? So it's kind of a hard task to do this disambiguation and do it accurately. So that's what this whole pipeline is for, showing you all of the steps for it. So I won't go into that right now, but we can talk about it more later if you want. But that's in production. It's in production as of, I think, December of last year. So if you go into, it's not an ADS actually, it's only in our SciEx and our new UI. You can go through and look up papers that mention Cassini or whatever else like that. Okay, and then another data enrichment pipeline that we're working on is for UAT, the Unified Astronomy Thesaurus, which is a hierarchical curated set of keywords. If y'all haven't heard about it, you probably haven't submitted a paper to AppJ lately. The AppJ keywords, when you go to submit a paper now, the list of keywords is all from the UAT. And it's hierarchical, so, you know, you have the top level where it's like extragalactic astronomy, and then it goes all the way down to like the SZ effect for cosmology. So you can choose anywhere within those keyword hierarchy of what you want to tag your paper with. But of course, AppJ's only been using that set of keywords since about 2019. So older papers don't obey the UAT keywords. Papers that are not in AppJ or similar journals don't obey these keywords. So if you're trying to find all the papers about the SZ effect, how do you do that? You can go search, or the UAT is meant to help you be able to specifically find those. So we're working on, with Indus, the model I was mentioning, we're working on training up a model that will go and identify and assign keywords to papers that don't already have them. And similarly, we're using AstroBert to do discipline tagging. So we have all these astronomy papers, but how do I say what is an earth science paper? What is a heliophysics paper? We haven't been doing that as long, and so we need a model that will help us identify the heliophysics paper specifically. So we're using AstroBert to work on a pipeline to tag all these papers with keywords and with disciplines. Oh, and there's a note. One thing that makes this difficult is the training data is really sparse and biased. So it's a harder problem than it seems at first. Okay, and then moving on to our third area of initiatives, area of interest, is data discovery. And this is much more experimental. And I don't think any of this is in production yet. We're just trying out a whole bunch of things to see what's useful for people and what we can actually accomplish. So this first project was done by a student that we're working with, a master's level student at Harvard. So he was trying to figure out how do we translate natural language queries into our specific ADS Solr syntax queries. So say I want to find all the papers by Alberto, and I say, you know, tell me Alberto's papers, show me Alberto's papers from last year. Somebody needs to translate something needs to translate that into author Akamatsu year 2023. And so that's what Tanner was working on was a bot to do this. Turns out you can't just toss this into ChatGPT, or at least as of a year ago, you couldn't just toss it into ChatGPT and get like a structured Solr query. So he ended up with a slightly more complicated architecture. It uses he was doing some human reinforcement learning. I think he ended up with a RAG system, but this is, there's a GitHub link, which I think the slides will be available later. If you want to go explore this, this was kind of an experimental thing to try to translate here. Next up is the SciX Brain chatbot. Sergi presented this at ADAS last year. But this is basically our internal test bed for trying out large language models. So if you want to chat with the literature and say, you know, tell me all the papers by Alberto, summarize the papers by Alberto from last year, tell me about them. Right now, you can't do that with ChatGPT easily because, like we've talked about, all these papers are behind paywalls. So our internal test bed lets us do that. We have access internally to all the full text. And so we can go and chat with them and get more information. And so this has just been a test bed for us to try different things, trying different architectures, trying different grammars, again, experimenting with those natural language queries, comparing various open source models. We've mostly been trying various open source models here. So we can plug those into our own GPUs and run them internally. And we've actually been using those for our data enrichment pipelines as well. So the planetary features pipeline I mentioned actually uses this under the hood to verify as one of the verification steps about planetary features. So I don't know that we're going to release this anytime soon, but at least gives us our own test bed to try this stuff out. We've also been working on more user-facing chatbots. So we were experimenting with custom GPTs. So y'all probably heard that ChatGPT made it easier to create custom GPTs and release them to free users now, which is great. So we've been experimenting with making it easy to chat with our own help pages. And this is actually pretty cool. This lets you create code to interact with the ADS API. So we have a lot of people who want to use our API and are maybe not very technically literate and not comfortable writing Python code. So you can go and ask it. I said, how do I use the ADS API to create a library of papers about exoplanets? And we fed it in all of our API documentation, so it actually does a pretty good job. It will go and just write you API queries. So I think this one's now available in ChatGPT. We haven't publicized it because we're trying to fine tune it a little bit more. This is still under development. So hopefully we hope to be able to advertise these things soon on our site. Okay, yeah, so that was everything that we're doing. This is just a summary of everything that we're working on. I don't really want to go through it. I do want to say just thank you. And also one thing I forgot to say is we are hiring. So if y'all are interested in working on any of these things, come talk to us. The position we have open right now is for a search/back office person. So somebody who has, if you have any experience with search engines or with Java or with Python, come talk to us. But the job ad's open now, and we'll probably be hiring for a straight up Python developer later on this year. So come chat with us. Thank you.